Everyone, welcome back to my channel. I know that it's been a while that I've uploaded a video. So from now, don't worry. Every week you will get one video for sure. That's a promise, you can say. So make sure that you subscribe to my channel and hit the bell icon. So as soon as I upload video, you get notified. So let's begin with this video. Very interesting video of circle. Now today in this video we are going to understand and discuss very important concept. So make sure that you watch video till end and hit like button and share with all your friends. So let's begin. Now since this is a video of circle, so let's have one beautiful circle over here. Now in this circle we are going to draw a triangle. Now observe this triangle ABC. This triangle ABC is inside this circle. So that's the reason this triangle is called as inscribed triangle. So whenever we have a triangle that is inside the circle, or in other words, you can say the vertices of this triangle, all three vertices A, B and C are on the circle. Such a triangle is called as inscribed triangle. Now suppose I remove one of its side, that is AC. If I remove it, so here we get an angle. Now if you observe, this angle is also inside a circle. So such an angle which is inside the circle, such an angle is called as inscribed angle. Now in this video, majorly we are going to understand and discuss all the concept regarding inscribed angle. So let's understand inscribed angle in more detail. See, if you observe this angle ABC, these angle have two arms. One is AB, other is BC. And B is the common vertex of these two arms. I hope everyone is clear till here. So in this angle, we have two arms AB and BC, and B is the common vertex. Observe carefully, this common vertex is on the circle. So this part is very important. You always need to remember, whenever we have inscribed angle, the common vertex is always on the circle. And the remaining two arms, that is AB and BC, are nothing but they are the chords of the circle. So whenever we have inscribed angle, two things you need to remember. First, the common vertex will be on the circle, and the two arms of angles are nothing but they are the chords of the circle. So let's see the definition. See, definition also says the same thing. An inscribed angle in a circle is formed by two chords that have a common endpoints on the circle. So see, so observe here, AB and BC are the two arms of this angle, and their common vertex B lies on the circle. That means these two arms are nothing but two chords for the circle. So AB is one of the chord, CB is other chord, and the common point is B, which is on the circle. So whenever we have such a condition, when the arms of angles are chord and their common point, common endpoints lies on the circle, such an angle is called as inscribed angle. Let's move ahead. If you observe carefully, there's an arc that is stuck in between these angles. So in angle ABC, there's an arc AC. See, observe, there's an arc AC which is stuck between these angles. So this arc is called as intercepted arc. So what is an intercepted arc? Whenever we have arc that is inside the angle and whose end points are on the angle. That means firstly this arc should be inside that angle, and secondly end points of this arc should lie on this angle. See, observe, arc AC, end points of arc AC is point A and point C. These end points are on the angle. So whenever we have such a condition, such an arc is called as intercepted arc. I hope everyone is clear with intercepted arc. Let's move ahead and understand some more important properties or relations of intercepted arc. See, firstly observe here. Here this angle is not an inscribed angle, agreed. But if you observe, there are two arcs that are stuck in between them. So this arc nothing but intercepted arc. So here we have two intercepted arc, that is arc QR and arc XY. Again, let's have one more example. Again, this is not an inscribed angle, agreed, but there is an intercepted arc, and over here intercepted arc is nothing but XZ. See, lastly, your favorite inscribed angle. Now think and tell me which is an intercepted arc. Very good, superb. Here intercepted arc is AC and this is an inscribed angle. Very good. Now if you observe in all these three examples, in first example for angle QPR, if you observe the common point, that is common endpoint P was in exterior of the circle. So whenever endpoint is in exterior of the circle, remember there are two intercepted arcs formed. Whenever the endpoints is in interior of the circle, we have only one intercepted arc. And whenever we have end point on the circle, again we have one and only one intercepted arc, and such an angle is called as inscribed angle. So for intercepted arc, it is not necessary that there should always be an inscribed angle, which is in our third case. It can be in interior or in exterior. Remember, the angle which the arc which stuck in between the angle is called as intercepted arc. So it can be inscribed angle, it cannot be inscribed angle, it doesn't matter, right? I hope everyone is clear with these three properties. So if the common vertex is in exterior, we get two intercepted arc. If it is in interior or it is on the circle, we get one and only one intercepted arc. Let's move ahead. See, observe again. We have one beautiful circle over here. And think and tell me, what is this? Inscribed angle, intercepted arc, what all things you can see? Observe here. See, if you observe, the common vertex B is on the circle. So for sure this is an inscribed angle. Also, if you observe, there is an intercepted arc. So here AC is an intercepted arc. Let's have one more inscribed angle. See, ADC. Again, this is an inscribed angle because the common vertex D is on the circle. Also, if you observe, for this inscribed angle ADC, the intercepted arc remains same. So we can say these two angles have common intercepted arc. So whenever in such a case, when there are two inscribed angle with common intercepted arc, in such case these two angles are always equal to each other. These two inscribed angles are always equal to each other. Remember, whenever we have two inscribed angle whose intercepted arc are common. So here if you observe, AC is an intercepted arc for angle B and AC is an intercepted arc for angle D. So these two angles have common intercepted arc. In such a case, these two angles are always congruent, and in reason we write angle inscribed. These two angles are inscribed angles, so angle inscribed in same arc are congruent. Remember, this is very important. This is used in many sums. So make sure you take screenshot of this page if you want, and this will be the reason for this angle inscribed in same arc are congruent. Let's move ahead and let's consider this same inscribed angle. So here we have inscribed angle ABC, and think and tell me which is the intercepted arc. Now you have to tell me. I've taught a lot. So here the intercepted arc will be very good. So here this is angle ABC is an inscribed angle and intercepted arc is arc AC. Now here there is very important relation between these two. So this inscribed angle and this intercepted arc, very important relation, very important. Listen very carefully and remember it. This angle ABC, inscribed angle, is always half of its intercepted arc. So angle ABC will be half of arc AC, and reason is very simple. You just need to write inscribed angle theorem. In coming video we are also going to learn proof of this theorem, but for now just remember inscribed angle is always half of its intercepted arc. So here angle ABC will be half of arc AC, and in reason you need to write inscribed angle theorem. I hope everyone is clear with this. Very important. Make sure you remember this, and if you want you can take screenshot of this page also. This is inscribed angle theorem. Now suppose I take one diameter AC and the center of the circle is O. Now if you observe, we all studied that whenever we draw a diameter, a circle is divided into two equal parts, and each part is called as semicircle, and measure of semicircle is 180 degree, always 180 degree. Very good, we have studied this. If you have not seen this video, you can just go through the circle series. It's in circle part 2. I have taught this in previous video, so you can just revise it, or you can visit in description. I will put the link. See, now observe here. Here AC is diameter. So this circle has two semicircle and each semicircle have measure of 180 degree. Now let's draw an inscribed angle. So here we have inscribed angle ABC, and there is an intercepted arc also. Now, since there is an inscribed angle, we'll also have an intercepted arc. So observe here, AC will be an intercepted arc. So we have inscribed angle ABC and we have intercepted arc AC. We just now studied a very important relation. Inscribed angle is dash of intercepted arc. Think, we have just now studied. Inscribed angle is half of intercepted arc. Very good. So here inscribed angle ABC will be half of arc AC, and AC here is semicircle. That means it is 180. So ABC will be half of 180. So ABC will be 90 degrees. So always remember that angle inscribed in a semicircle, this arc ABC is also a semicircle. So this angle is inscribed in a semicircle. So whenever we have angle that is inscribed in a semicircle is always right angle, or you can say 90 degree. Again, very important relation. Make sure that you remember this, and in reason we write angle inscribed in semicircle is always right angle. So whenever we have angle, inscribed angle, which is drawn inside a semicircle, it is always equal to 90 degree. I hope everyone is clear with this. Now there is very important and interesting topic that is called as cyclic quadrilateral. So I want everyone you to just research a bit about cyclic quadrilateral, and you can just comment what all things you have seen on Google or wherever in textbook about cyclic quadrilateral. And in coming video we are going to study and learn what exactly is the cyclic quadrilateral. I hope everyone enjoyed the video. Make sure before going you subscribe to my channel and share this important video with all your friends. Till then, goodbye, take care, bye bye.